Hi, welcome to my Cybercab video. If you have been wondering why the Cybercab has this kind of wheels and tires, you will sure find it out in this video. Some of the estimates are made on best knowledge, but mostly it's based on physics and should be quite accurate. So you will be finding out will these new wheel and tires save energy, why they are in the car, and what possible problems will come and what kind of savings you will probably get depending what kind of wheels and tires you use. So here are the specifications what we know at the moment. So the length of the vehicle was measured by one guy where the car was in show at some place to be 444.5 millimeter long. My estimates from 3 to 4 months ago when it was revealed was 4 to 15, so it was off 5%. The width of the vehicle was measured to be 1600 millimeter. My estimate was 1690 millimeters, so it was 5.3% wrong. And this can become, depending on the picture lenses, what kind of distortion it creates. And that's very difficult to estimate from pictures like you see here. You don't know what kind of lens was used, so it distorts the picture a little bit, and also you might edit the picture to become a little bit different dimensions depending what you want the car to look like. It's not cool, but that's what happens. So the height of the vehicle, 1406 millimeter is my estimate, and the wheelbase on my estimates is 2 meters and 676 millimeter long. I would estimate the car will be much lighter than Tesla Model 3 because there's no back seats and much of the other equipment is also stripped out. So with the one passenger, my estimate it will be 1,600 kilos. So while it's driving, that's the estimated weight. I have measured the frontal area to be 2.0 square meters and estimated the drag coefficient will be around 0.20 based on my best knowledge. It might be 0.21 because there's no tire deflectors in front of the tires, but that's the ballpark where I'm estimating it should be. The front tires in the car, what you see at the moment is in front 215, 16, 18, and the tires are Continental R Contact, which is a new tire for Continental, which is not in use, I think, in any other cars at the moment. And at the rear, the size is much bigger. It's 225, 60. So proportions are pretty same, but the diameter is 3 inch bigger. So that's a quite lot bigger rear wheels, and that's causing problems. They have said it for efficiency reasons, but I will prove it that that's not the case here. So let's start with rolling resistance, where it actually shines if you have a bigger diameter of wheel. First, you have this kind of Chalmers final study. I will post all the related documents that are used in these calculations on the video, so you can look them through yourself. But here's a picture where you can see the rolling resistance is directly related to the diameter of the wheel of the tire. So bigger tire diameter you have, the smaller rolling resistance the tire will have. So the rear tires are 10.9% bigger in diameter in the Tesla Cybercab. And if you put that to that picture, which you can see there, the rolling resistance will drop about 6%. And that's the rolling resistance. And now we can start to calculate what's it's actually for the energy consumption of the car. So difference in rolling resistance is 6%. And my estimation that the rolling resistance for the tires used in this car will be 0.6. And if you put it 6% lower rolling resistance, you get 0.564. But you have only two tires, so it's half of that, so it's minus 3% only in rolling resistance. So that's the number to remember. And we have calculated now different consumption at different speeds and what the rolling resistance impact is. The slower you drive, the rolling resistance is higher portion of the total energy consumed. But there's also a twist here because the rolling resistance is not constant depending on the speed. It also increases when you're driving faster. So that's why you can see that if you have 3% lower rolling resistance on those two tires, its impact to consumption at 40 km per hour speed is only 1.03% lower consumption. And if you drive 80 km per hour speed, it's 1.1%. And if you drive 121 km per hour speed, it's 1.1 also. And from that, it should be starting to get lower and lower, little bit, but it's around that 1% the whole time. If you look the consumption curve for this car, it goes quite little energy, as you can see. Here on the bar, you can see kilowatt hour per 100 kilometers, and here's the speed, and sadly I'm blocking the numbers, but that's kilometers per hour. So at 60 kilometers per hour, the car will consume only 5 kilowatt hour per 100 kilometers. If you go to 100, it's like 10.5 to 11 kilowatt hours, so it doubles. But the consumption is very low. They have estimated the battery size of this Cybercab to be under 50 kilowatts, and it should reach about 300 miles range with the battery, so almost 500 kilometers. But it can be quite low, depending what kind of average speed you're estimating for the car. It's closer to 40 kilowatt, I would assume, and that creates that the weight of the vehicle will be quite low compared to the Model 3 because you can use so much lower battery size. So that was 1% better consumption, so that's a plus for the big diameter tire. But that's not all. When you change everything in wheel and tires, it impacts everything in the car. And I have here calculated some of the things it will impact. Here from the same study, the rolling resistance change how much you actually load the tire based on its maximum load. And here we have a chart from 175/70 14-inch tire, which maximum load is 500 kilos. So here 5,000 Newton meters is about the maximum load it can handle. In EU cycle test, I think the measured load is much lower. So you're not using the maximum load in the official test. You're using some number, and I will not guess here what the actual number is, but it's like 60 to 80% or something like that. But now let's start to think about this. We have 215, 16, 18 tire at the front, which load index is 98. That means it's able to carry 750 kilos max load. So here 100% is 750 kilos. We had the estimated weight for the whole car, 1,600 kilos. And now if you put that divided by 4, that's 400 kilos per tire. And you put it here, 400 kilos is like 54 or something percent of that 100 kilos. So it's right about here. And its rolling resistance estimate, these are not comparable, it's depending on the pressure and everything, but it changes the same way on the higher pressure, just the values are different. So here is 0.0111 for that front tire. Now when you change the diameter so much in the rear tire that it's 3-inch bigger and it's a little bit wider, 225/60 R21 is a tire size which is non-existing at the moment, but I have evaluated what the actual load rating for the tire will be, and it will be 103. That means one tire can carry 875 kilos of load. That's much more. And you put it again, that 400 kilos to 875, you get it, it's like 46% or something like that. You put it here, you get a rolling resistance value of 0.0122. And if you compare how much different there is, the rolling resistance will get 9% higher on this tire, which is not loaded so much. So you're already losing here on this second slide, that you're not gaining any more range, you're actually starting to lose range already on the second slide. That's why when you are trying to make efficient cars, you should always have tires which are loaded as close to as possible on the maximum axle loads you have on your vehicle. That's why I have selected the 205/60 18 for the Model Y, where the same load index is 750 kilos. And there the maximum axle load is 1,500 kilos. So it's on the max when you have it fully loaded, and it's close as possible to the maximum load when it's not so loaded. Because if you look these values, they get higher all the time. Here I have calculated how much higher it gets every time you put 10% less load. The first one, it goes, if you have only 450 kilos loaded, it's 6.1% worse. If you have to, then again take 10% out, it's 6.8, and the first one, if you have only like very little load on the tire, it's 11.6% load. So efficient is going totally wrong way if you're not loading your tires. Let's move to the next slide. So here I found a few days ago very nice study from Mercedes based on W213 model series, which has been made from 2016 to 2020 E-class. And there it says also E-class. What's the impact if you change your wheel diameter, dimension, the pole design onto your CO2 cars consumption? Because now EU changed the rules that you also need to take into account the wheel design in your energy consumption of each model. So they made a study and how it actually impacts the consumption of your car. And if we start to look this, you can see that it has some quite interesting data here. The base model energy consumption or pollution is 122 grams per kilometer on the reference wheel 7x16 ET32 205/65/16. That's the lowest energy consumption model wheel and tire combination they have. They have taken out in these pictures the actual tire rolling resistance is same on the all tires, and the aerodynamics of the tires is also the same. So it's purely in this picture here only about the wheel aerodynamics and the size aerodynamics. So everything else is taken out from this picture. So if you go 1 inch higher, a little bit wider tire from 16 to 17, the impact is only 0.8%, so not very big impact on the energy consumption. But when you start to move to higher wheels, like here you look the AMG line, here it's already 5 grams more, so the 122 plus 5 is 127, so AMG line starts from 127 grams CO2 levels, and there you have first a squared setup, so you have 245, 45, 18 on all corners, and if you put wider tires to rear tires, the impact is only, so here 30 millimeter more wider tire at the rear, a little bit wider wheel, 1 inch wider wheel, impact is only 1 gram. So very marginal impact on the consumption also here. But when you move to 19-inch wheel, then it's already 2 grams. And when you go one size more, then it's 14 grams. And 14 grams difference between the 14 grams and the 6 grams is 5.8%. And that's only 20-inch wheel. And in the Cybercab, you will go to 21, so even one more. There you have the benefits that, of course, you have the smooth wheel covers there, so the impact is not so big. But I have estimated that because the rear tire is a little bit wider, that's 1 gram on this scale. And if you go 3 inch higher on the diameter, that's 1 gram per each inch. So total 4 grams higher CO2 on this scale, which means the consumption will be 3% higher on percentage. And because you have only 2 tires in the rear, that's 1.5% higher consumption. And that's same for the energy consumption. Is it diesel or electricity? The scale is the same because it's purely related how much you burn stuff or consume stuff. So here, from aerodynamic perspective, you have minus 1.5 or higher consumption plus, depending which way you want to calculate it. It's not all. I have plenty more coming. The bigger diameter wheel also impacts your rotating masses of your car. And when you have a lightweight vehicle, its impact is bigger than in the big heavy vehicles. I have played with this already, all my project cars, and I have been finding that if the car is very light, the aerodynamics plays very big role. But when the vehicles are heavy, like my ID3 project car, the rolling resistance also plays big role. And also the weight of the wheel and tire package plays a role. Lighter the vehicle, the bigger impact the lighter and wheels and tires you have. So here we have calculated how much the actual weight of the wheel and tire will get higher and what's its impact to the whole car's kinetic or potential energy is. First, I have calculated 8 times 18 wheel, how much it actually probably weighs. In my estimate, the wheel in the Tesla Cybercab should be around 11 kilos for the wheel. The tire, 215, 16, 18 weighs 10.9 kilos on current Continental models, so that should be quite accurate estimation for the tire weight. And now I have compared here these two similar wheels that are same width. Just the diameter has been increased and the load index in this wheel is same and the design is same. So here this wheel weighs 16 kilos in 18-inch size and 21 kilos in 21-inch size. And from that I have got the number which I have used to multiply that 11 kilo wheel in the same strength will weigh in this case 14.4 kilos. And from that I can start to calculate what's the inertia difference is for this wheel, how much there is on the tire outer dimension rotating weights and how much the side of the tire weighs, and same for the wheel. And here you can see the dimensions that for the tires it's much more important to have a lightweight tires than there is lightweight wheels, because the heavy weights are bigger diameter, so the impact on the inertia is bigger easily. So it's here tire inertia is let's see, it's not so clearly put here. I need to once look it too. so I don't say totally wrong things here. So inertia for the 18-inch tire is 1.245, and inertia of the wheel in 18-inch size is 0.51, and total is 1.755. And if you go to bigger tire, that 21-inch, that inertia of the tire jumps from 1.2 to 1.8, and for the wheel from 0.5 to 0.93. And if you sum those together, you get 1.75 against 2.749, and that's 56.6% difference in the rotating inertia. And what that does, you need to calculate what's the impact is for the whole car's inertia compared to is, and how much that actually changes. And here I have tried to calculate that. The whole car's inertia, if the car weighs is 1,600 kilos, is first the inertia for the whole car. So wheel and tire calculated together, the inertia is here, 4 to 120, and if you have the bigger 21-inch wheels, is 5 to 6 110. And you calculated these together, you get 94730. The whole car's kinetic energy with 1,600 kilos is 600,013. And if you have 4 same tires as in the front, that wheel and tire kinetic energy is 13.7% of that mass. If you have then 2 of the rear tires bigger, that's 15.4%. So the difference is 1.7% if in the kinetic energy you get higher because you have heavier wheels and tires at the rear. I have calculated in my estimation that the car's efficiency from the battery to the road is 85%. And in city driving, you do regain most of the energy back, so impact is not so big. But my estimation is that 81% of the energy can be recuperated. So you multiply that, and there I have got a rough estimate that 31.1% of that difference in energy is lost. And that's they're calculated, and it's 0.5%. This number is not very accurate, I can surely say that. Might be much lower, but it depends how much acceleration and braking you do in the city driving. So if you drive in the city, you do that all the time, depending on the city size, more or less. So it's between that and 0, I would estimate. But again, you are losing energy if you have higher rotating masses. Well, how does the actual wheels in this Tesla Cybercab look? There's rare pictures of the car without the aerodynamic wheel covers. The most efficient choice almost always is that you have a very lightweight wheel with the aerodynamic wheel cover, and you will get the longest range with that way. So here the wheel design is like flat 5-spoke wheel, which looks like to be a very lightweight design. Same design front and back, just a little bit scaled it up. You can see the spokes are in the rear going more closer to the outer edge of the wheel. So that's for strength reasons. If you hit potholes and stuff like that, it's not so great on the bigger wheel. The bigger diameter wheels are always weaker. You need to put more material there to make it strong and last all the stresses there is for the wheel. In this case, the tires have pretty high profile, 60 both of them, so there's a lot of rubber to flex before you hit the pothole, damage your wheel, so that helps. Then let's look about the results, what we have calculated. Rolling resistance does get lower if you have bigger diameter of wheels, about 1% in this case. How much you stress the wheels, in this case, the consumption will get 1.5% higher because you're not stressing that tire so much if you would have smaller wheels and tires. Bigger wheel size will hurt your aerodynamically. I only calculated it roughly. Impact might be bigger or worse, but it's around 1.5%. I'm pretty sure of that. Rotating mass, if you have bigger wheels, it impacts also your consumption. My estimation 0.5% higher consumption. And if you calculate all this together, you get your Cybercab bigger real wheels. Impact is 2.5% higher consumption in real life. And that's not good, but in this case, it really doesn't matter that much because the energy consumption was so low to begin with. So why are there the wheels at the rear? I have always thought that the bigger rear wheels makes only sense if you are using in-wheel motors at the back, and that makes it engineeringly wise choice because bigger motor size you create more torque and etc. etc. It's better for in-wheel motors to have bigger diameter for performance, but you don't need that much performance in city cars. So at the moment it seems there is no in-wheel motors coming to the rear. It might be coming later or it's not an option. Other way to look at it is why would a car manufacturer like to put totally new tire sizes to any car? That's because they want to sell you expensive tires. That's the truth. If you buy 18-inch wheels or tires, they are almost half the price than you are using in, for example, Tesla Model Y, depending what kind of tire you choose. So if it's a very popular size, you can find many brands that are using that or making that tire, and that makes you possible to select a tire which are suitable for your needs, performance and money-wise. If you have only one option to buy like BMW i3 tires for winter tires, you can basically say any price you want. If you want to buy a real winter tire, there's not many choices. So you pay premium on the tires. And probably the most obvious choice is the design has said that we need to have bigger wheels in the rear because it looks cooler. If you look at the picture here, you have a flat panel there at the rear. The bigger the panel is, the more dull it actually starts to look. So if you cut a bigger hole there, it looks maybe sportier, and that's probably why there is these bigger rear tires in real life. So it's purely a design choice, most likely at this point. So what are the possible problems with these wheel and tire solutions? I have already said that there are wheel covers in this car, but I haven't said that the wheel covers are actually oversized to make the wheels look actually bigger than what they actually is. When I looked the first videos we saw when the car was released, I didn't actually notice that the rear tires are so much bigger. I noticed that there's something weird going on, but I didn't see what it actually was. That was because the wheel covers are not same size. They are scaled a little bit differently to take away the actual size impact here. So it's not so clear to see the difference what the actual wheel size is or what the actual tire size is, also because the sidewalls of the tires have the color. And here I have taken the picture which I made that 3 months ago, the actual 215 6018 tire size is 750 millimeter on the outside diameter, and on the rear tire it's 803 millimeter. And now if you look the wheel cover diameters, in the front it's 600 millimeters and 50 millimeter more at the rear. So about 10% difference also there. It was 10.9% different in the tire diameter. But if you look how it is then closer or to the tire outer edge, here again you can see that the picture distortion starts to maybe play a role. At front I can measure that it's 57.5 millimeter you have before you hit the curb on the tire side. And I know there's like over 100 millimeter there rubber. So it's coming a long way on the tire side to cover more of the tire. And at the rear I can measure 76 millimeter, but there it's not so clear. You can see there's light coming here on the side of the rear tire, so there maybe the picture distortion is causing a little bit problems there or something, as I haven't been fully get out what the actual this is. But what is sure that if the gap is 60 to 76 millimeter for the wheel cover, if they are painted like they are now in the first version gold, those wheel cover will get curb rust almost immediately on the first drive you drive even close to any curb, because they are the most outer part of the assembly, and that will start to scratch, and depending how it's made, it starts to look bad or really bad. And that's why you have been already seen videos and pictures already that they are testing black wheel covers in this car, because that's the only sensible choice to have if you want to have it like that. But then again, why would have bigger wheel covers there if they're not painted? If they're black, they look black. And same for the tire sidewalls. When you paint it different color, they will start to lose color every time you hit the curb. So that's one problem. Now here comes the one actually big problem reliability wise, is if you are using bigger diameter wheel covers than your tire or wheel is, when you drive in bends or over the curbs, when the tire flexes, it starts to hit the hard wheel cover like this, and it will start to rub pockets in the tire. And I have tested this already like 14 years ago in one my Seat project car at rear. There was quite big pockets in my new tire, and I surely made it smaller, the wheel covers, because of that. In the Cybercab, they no, not Cybercab. The stainless steel version car, they had the wheel cover problems also similar way, but there they had softer material on the wheel cover outer edge, so it flexes more. But still, if you have a bigger diameter wheel cover, what happens if you happen to get a rock between the wheel cover and the tire? Think about that. That's what actually happens in heavy trucks every day. Between the wheel and tire, you get small rocks. They start to grind the tire, they start to grind the wheel, and both of them are ruined sooner or later. And that's one of the bigger problems what I can see already happening here. If you're running oversized wheel covers, it's nice for the looks, it's nice for the efficiency. If you have bulky wheel cover tire outer side, it covers it nice and it's best for the efficiency, but it will sure create problems sooner or later. This was my review on the matter. If you know better what happens here, let me know. Tell me your opinions. Have I calculated something wrong? That's totally possible. I'm no expert in Excel especially, I have calculated more accurate numbers on my Tesla Model Y calculation for new wheel and tire, but luckily the wheel and tire I'm designing, it's also fitting this Tesla Cybercab. It's a 5-bolt pattern wheel, it seems, and the size is pretty much the same. So I'm eagerly waiting more details when these will be on the road and what the actual wheel and tire sizes will be in the production version. Will they still keep the bigger wheel size even it's hurting the efficiency, or will they do something smarter and make some design changes or everything like that? I'm not believing in design changes in this stage, but still it's possible, because if those wheel covers are not working like they should, or they are creating too much problems, they have to change it one way or another. Thanks for watching, and keep watching my videos. There's more stuff coming.